Okay, I'm going to talk about pH. I always look at pH as a result, not actually something that we should drive our decisions on the farm. Really, it is percentage of hydrogen in a negative logarithm. Now, just to make it really simple, what it means, the lower the pH, the higher the acidity. So what's going on? Well, the reality is, when you did the cation exchange capacity, you measured the negatively charged sites in the soil. Hydrogen is a positive. It's the weakest of all positive charges and easily exchangeable. Every negative site in the soil will be filled with a hydrogen as long as there are no other cations. So if there's no calcium, magnesium, potassium or sodium, hydrogen will go onto the site. When that happens, the more hydrogen there is, the lower the pH. And we start at a scale of 1 and we go to 7 being neutral, and then you go to an alkaline of up to 14. So what's happening in the soil is you will change the pH by changing the cations. So when you look at the soil sample, you need to look at the cations more than you look at the hydrogen. It's great, the pH is utilised when you measure the parts per million of these minerals against the pH. Use that as a calculation, then it will tell you the percentage of how much of these minerals are in the soil. And then you can work out how much you need to apply to increase the pH. But always remember, pH is a result, not something you should gauge what you should do next. Because if you look at magnesium, on high magnesium soils, the pH might be 6.5 up to, I've seen it up to 8 in the States. And yet, if that isn't completely out of balance with the magnesium, that might have a very high pH and you would decide not to apply anything. Yet it may respond incredibly well from calcium to get the balance right. Now we'll go into those equations later, but this is the reason why we don't want to look at pH as a driver of decisions on how we go about making our fertilizer applications. It's very, very dangerous. So when you look at it, you look at your pH test, but then go down and look at the parts per million of the major cation drivers, and then look at how that can change. Like, I'll give you another example. If you've got really high sodium soils, you might have a pH of 7, and yet you might desperately need some calcium magnesium in the soil to actually open the structure up to let the sodium drop out through some moisture. And also, your pH might be affected by aluminium. And so aluminium is a positive, and it becomes into solution when it starts to get a little acidic. So aluminium kicks in around about 5.5. So that will buffer the pH and keep it there. Aluminium is no good in our soil as far as the base saturation is concerned, but so it's having an effect on the pH and saying, oh, it's not too bad. But when you look at the rest of the major cations on how it should be built up, if that's buffering the pH up, you're in big trouble. So just look at the pH as a result. Look at the calcium, magnesium, potassium, sodium, and other issues like aluminium as your decision makers. And we will go into that further as we go into the more tutorials.